and we installed a tripper right at the portal, which allowed us to then incline the belt up to approximately 12 degrees, bring the belt out and over top of the belt storage unit. This allowed us did not require the use of a vertical conveyor. And with soft ground applications, we try to do that to eliminate the number of conveyors required. This was a relatively long open cut, and it was relatively shallow. So we did eliminate a vertical and transfer the material up to the surface. One of the things that you have to keep in mind when you're putting any belt conveyor system in is what type of material are we going to be conveying. In UTV applications, that can be very wet, very sloppy, and sometimes very sticky material. When you get into these very wet, very sloppy, sticky materials, and even in hard rock applications, you want to keep the belt clean. And something that we've developed is the Conveyor Wash Box, which utilizes water sprays and air knives to clean the belt. Some of the advantages that we've seen with the use of the Conveyor Wash Box is that when the conveyor is going to be shut down for an extended period of time, if you go ahead and cycle the entire belt through the wash box before you shut it down, then when you come back after several days of being off, the belt has dried out, you won't get the dust in the tunnel that you normally would have seen if you have a dirty belt in the tunnel. The wash box cleans this off and significantly reduces that dust. Here you can see this is the incline on the Upper Northwest Interceptor project. As I said, we brought the belt up to 12 degrees and conveyed material up that incline with relatively no problems. This was very wet, floppy material. It was not very sticky because there were foam and polymers were added into the system so that it would not be sticky. You can see in this pile it was very wet. Sometimes there were clumps, but conveyed on the horizontal conveyor very well. The use of the belt conveyor system in this tunnel allowed them to set some advanced rate records, and the conveyor on the system operated at 90% availability. These rates could not have been achieved with muck cars because of the inclines in the tunnel itself. Now, we have another poll question. If you would please take the time to answer the question.
And Jean, we have an interesting question while people are answering that. Are there certain materials that are difficult to convey, and how many different types of materials can one system carry?
The question is, are there different types of materials that are difficult to convey, and how many different types of materials can the conveyor convey? Once you have loaded the material onto the belt, it normally is not difficult for the belt to carry it. What you have to do initially is design your transfer points for the different types of materials that you're going to be expecting. With hard rock tunnels, you're not going to get for the most part, the wet, sloppy material. You're going to be conveying our TBM chips. If you're looking at EPD applications, then you have to keep in mind that, okay, I'm most probably going to have wet, sloppy material. We need to enclose these discharge points. We need to put skirting on. We need to put skirting on that is longer than would normally be used in a hard rock application. And while we're waiting for everyone to answer, I hope that answers your question. That is one of the most difficult things in designing belt conveyors, is trying to predict and decide what types of materials are we really going to have. But that's one of the issues in tunneling, and that relates back to what is the geology. Okay, we have our answers here to the question. And as with our other questions, we have a lot of people interested in another number of different things. So that makes it difficult in the limited amount of time that we have to try and answer every question or to concentrate on one part for the rest of the presentation. But I will continue with the presentation, and like I said, we will try to answer all of your questions at a later time. To conclude the presentation, I think belt conveyor systems have proven themselves to be the most efficient and reliable means of muck removal. I don't think anyone can argue with that at this time. They have been used. All the world records for tunneling advanced have been broken and set using belt conveyors. And in order for TBMs to achieve the advance rates and set the records that they have, I think the use of belt conveyor systems belt conveyors will be used for many years in the future. One of the things, and I just want to touch on briefly, though, is with the belt conveyor system, you always have to properly maintain it. And that is one of the problems that we run into throughout the world, is, especially with the TBM conveyors, is initially you start out with a very short conveyor. You have a lot of power, you have a lot of belt strength there, which is not required. It's very easy to abuse the system initially. Then when you reach the long length where you're really requiring all of the belt strength and all of the power in the system, you will have problems. So it's like any other piece of equipment. You have to maintain it, properly align the belt. But with the Robbins Company, we have full service people and experts around the world to assist with that. Now, we just have a few minutes left, but if there are any questions, please submit those questions. Like I said, we will try to answer your questions, and if we do not get them answered today, we will respond to you at a later time.
Hi, Dean. The first question is, what is the smallest diameter of tunnel where a conveyor system can be used?
The question was, what is the smallest diameter that belt conveyor systems can be used? And that is probably, I don't remember what the exact diameters, but we have designed conveyor systems to be used in as small as an 8-foot diameter tunnel. Now, that is a very tight tunnel for the conveyor, but we did design a system bore tunnel of 8-foot diameter.
Are there standard conveyor belt specifications that are typically used?
The question was, are there standard conveyor belt specifications?
Mm-hmm.
There are specifications on each and every conveyor belt, but one of the things, especially when you go into extensible conveyors for TBM applications, each system is custom designed, and the specifications are then set based on the requirements of length, capacity, and material that will be conveyed.
A related question, how many plies are typically used on a conveyor belt?
Typically, the belting that is used, the fabric belting, is a single ply. Sometimes for the TBM extensible conveyors, it could be a 2-ply belt. I know belts are available that are multi-ply belts, but in TBM conveyor applications with horizontal curves, we recommend the single-ply belt because the belting, when going through horizontal curves, has belt edge pressure, and what we saw with multi-ply belts is that you will see ply separation when that belt is edge pressure on it.
Is there a price difference between steel cable and fabric belting?
There is a price. The question was, is there a price difference between steel cable and fabric belt? To answer that question, yes, there is. 10 years ago, steel cable belt was very, very expensive as compared to fabric belt. The price difference has came down, and in some applications, the steel cable belt can be less expensive. But that all depends on the type and the strength of the belt.
Is there a difference between how long fabric and steel cable belts can last after extensive use?
Question is there a difference between how long steel cable or fabric belts can last? And the answer to that question is no. If the belt is properly designed for the application and the system is maintained and operated per specifications, both beltings should give years of life.
Are there specific types of projects where you would recommend an S-type or a J-type vertical conveyor?
The question is which conveyor would be recommended, a J-type or an S-type? The advantage of the J-type is that it, as I said, very small footprint, and the belting is readily available. It's my feeling that the J-type can be used almost anywhere that the S-type conveyor could be used. Are there any more questions?
Yes. Would it be reasonable to install a vertical conveyor in a shaft where ground surface area is limited?
If ground surface area is limited, you would want to use the J